Okay, let's practice writing some programs that use Python. We will go through the design process and the implementation process. So, first, let's write a small program that is a pass-fail. It displays if you passed or failed a test. So the idea here is that the user will enter the amount of points an exam was worth and the amount of points that they scored. Then we'll calculate their grade percentage with this formula. And if their percentage was greater than or equal to 60, we'll display pass. Otherwise, we'll display fail. So let me open up my diagramming tool. And let's think about how we're going to do this. So the user has to enter two pieces of information. So we need two variables. Let's name them exam worth, I guess. Again, it has to be descriptive, but it doesn't have to be exactly what I wrote. Then amount of points scored. So let's say points scored. So they'll at least enter that starting information. Then we need to calculate their grade percentage. So to get that, we take the points scored divided by the total and then times 10. So we'll just say percent is equal to the points scored divided by exam worth times 100. That will give us a percent from 0 to 100%. And then we check to see if their percentage was greater than or equal to 60% or not. So this will just be a question. Is percent greater than or equal to 60? We're not going to use the percent sign because we're just going to be using floats or integers, probably floats, because you could have like 20.5 points, right? So we'll do that. And then if they pass or fail, we'll display that. So display pass, display fail. Make sure not to forget to label these outcomes. This is when it's true. This is when it's false. And then the program ends after that. Either way. So we'll just point those there. Okay, so there is our program design. Now let me make sure I have REPL open. We can work on it in Python. So we'll just name this PassFail. Okay, so we'll just start off by asking for the input. Exam worth is equal to, usually the points would be integers, but let's go ahead and just make it a float. Float input, how many points is the exam worth? Points scored is equal to input, how many points did you score? Now we'll calculate the percentage. Let me just expand this a little bit. Percent is equal to points scored divided by exam worth times 100. Now we ask the question. If percent is greater than or equal to 60, then we'll display pass. Otherwise, we'll display fail. And then the program ends, so we'll just say end there. So that will be our program. Now if we run it, we can test it out. Let's say we'll just keep it at like 200 and we scored 100 points would be half of that, so that would fail. Do 200 points, let's say we got 185 and that's pass. So that's that one. Okay. Next one, battery charge. Have the user enter the amount of charge their phone has as a percent without the percent sign, because we can't really work with that as a variable type. Based on their response, draw a little diagram of their battery. So just some basic keyboard keys, the square brackets and asterisks and underscores, and we'll basically try to represent what their charge is based on that. I'm not going to make a diagram for this one because this is just going to be a bunch of if, else, if statements, so we'll just jump into this. Let me go ahead and make a new one. This will be battery charge. So we'll say battery is equal to int input. What is your battery charge? And we'll keep it as an int. They could enter like 90.5, but that's not really the point of this. They're going to enter a whole number. Usually those are a lot nicer to look at in like your charge screen. So we'll say if battery is greater than or equal to 90, we'll display a full charge. Okay. Else if the battery is greater than or equal to 75. Now, it does say between 75 and 90, but if this part is false, that means we know it's already less than 90. So we don't need to add that as an extra command. We'll say print, and we'll do 1, 2, 3 with a underscore to be the empty space. Okay, we got between 50 and 75. Again, if this fails, it's less than 75, so we don't need that part. 25, and then the lower one is going to be a little different. So here we'll replace this asterisk with an underscore. We'll have 2 underscores, and then here we'll have 3. But this one is going to be if the battery is lower than 25%. So I could type this out, or I could just say else, and that will catch it no matter what. So here we'll run this. I should have put a space in here to make that look a little nicer. Battery charge 100%. So we get that little diagram. Okay, how about 85%? 55%? 35%? 5%? And so those are those different little art graphics. Okay, calculating a running total. So, sorry, I was just dropping my shoes on the floor. If you can hear that background noise. Write a program that asks the user to enter a series of positive numbers. These numbers will be summed into a running total. Use a loop to continue looping. If the user enters a negative number, then stop the loop and display the final sum. Tracking a negative number, tracking a negative number will, to signal that we're stopping the loop, is known as a sentinel value. So anything negative is like a special flag, like, hey, we're trying to do this thing, but there's certain special values we're looking for to mean certain things. Oops. Okay. And I have a cat tail in my way. I'm trying to type. All right, so we have our program start. We will want to keep asking the user to enter a positive number, but that means we're going to need to start a loop. Also, to do a running total, we need to have a sum variable, and we want to set it up before the loop starts. We need to initialize it to 0. Otherwise, when we try to add to sum, there won't be any sum there once we're doing like sum equals sum plus whatever the user entered. It's just not going to work. We need to make it before the loop, and we need to set it to 0. So then we'll say is user answer less than 0. Now this is also saying user answer. That's going to be another variable. We don't have a variable yet. That should actually be a rectangle. We don't have a variable yet for the user's answer. And Python doesn't allow do while loops either anyway, so we're going to just create one user answer and set it to 0 to start with. That's kind of our starting value. If we add 0 to the thing, it doesn't matter. It does nothing. So it'll at least start the loop because user answer is 0, not less than 0. And we can start from there. Now, if they entered a negative number, we want it to just quit and display the sum at the end. So we'll just say display sum and then the program ends. So this will be the false case, or actually, I have this backwards. Since the while loop is going to run with what's true, if it's greater than or equal to 0, it's going to loop. If it's not, it's going to exit. So false in this case means user answer is less than 0. Okay, so in the true state is where we actually do our whole main program part. So first, we're going to ask the user to enter a new number, their user answer, user input, user answer, and then we're going to add that to the running total, our sum. So here we have the sum. Sum is equal to the sum plus user answer. And then we're going to continue looping. Now, we have a problem here. There is a logic error in here. If we run this, we start the loop. Let me write a little thing. So we'll say user answer is 0 to start with. Let's make that a different color. So we enter this loop. The user enters their answer. Let's say they enter 5. So then it's going to get added to that sum. So let me go ahead and make a sum variable. Sum is now equal to 0 plus 5, which is just 5. So that's what sum is at the moment. Then it's going to come back here and say, is user answer greater than or equal to 0? Well, the user has entered it for this past loop, but they haven't entered it for a future loop. So if we go over here and they happen to enter -5 to stop, it's going to come down here and say, oh, this is now the sum plus whatever that value is, so it's going to subtract from it. And then it'll come back here and then exit the loop. So we actually could do this a different way. We could have them calculate the sum first, because in this case, the user answer starts at 0, so it would just add 0 to the sum, which really doesn't matter to us. That's fine. So is it 0? Yes, we'll add to the sum. 0 plus 0 is 0. That's fine. And then we're just rearranging these. So then we get them to enter their answer again before we do any math. So enter the next value. It's 5. Okay, is that greater than or equal to 0? Yes. Okay, add that to the sum. 0 plus 5 is 5. Go down here, enter the next one. Let's do 2. Go over here. Is it greater than or equal to 0? Yes. Okay, 5 plus 2 is 7. Down here, get their answer. They say -1. Come back up here. Is that greater than or equal to 0? No. So then it will exit. So that way we don't have that logic error. So we will then implement this in REPL. Let me find it again. I need more monitors, I think. This is an old program. There we go. Set Python. This is going to be running total. So program starts. We are going to set the sum to 0 and the user answer to 0. And we'll say while user answer is greater than or equal to 0, we'll have them, well, first we'll sum whatever that value is. So sum is equal to sum plus user answer. We'll ask them for the next value. So user answer is equal to, let's say float. They could put 3.5. Input, please enter a number. And then it will be able to go back up here and check that. It'll keep adding to the sum, and then down here we'll just say final sum is the sum. Now, it could also be useful to know what the sum is while we're calculating it, so let's go ahead and do that too. We'll just say that current running total is, and whatever the sum currently is. So we can kind of see it as it's running. So let's go ahead and test it out. let's do 5, 5, 6, 7, and so that's doing that, and we can do -1, and 23.0 is the final one. It didn't decrement it at all. Now I will say I didn't put in the instructions anywhere that you type a negative number to quit, so this is actually kind of a bad user interface. So I'm going to put a header. I'll say this is some program, type a positive number to add to the running total, or type -1 to quit. Technically they could type in any negative value, but it's a little bit easier just to say, just type -1. So then we can start doing our sums, -1 to quit, final sum. I would put another empty print line here just to separate that out a little more, so you can kind of see it by itself. Okay. What's next? Calculating an average. So we're going to adjust that same program, but we're going to make it an average. So we already have our sum. That's the main thing we need, but then we also need to count how many times we've added onto the sum. And we can use that to calculate the average. So let me see if I can make a copy of this. Does that have an option for copying code? I'm sure it does. I'm pretty sure I've done it before. I don't completely remember how. So, oh, there we go, fork. We'll make this the average. Maybe eventually today. Okay, so now we'll call this the average program. While I'm being kicked by my cat, who's trying to give herself a bath while I'm trying to type here, and she's very mad about me trying to type. What a mean kitty cat. Okay. See, I'm right. There's another cat back there, over here. Okay, so we have a sum. That's part of the thing we need to calculate the average, but we also need to keep track of how many times we've added onto the sum. So let's do total items. Ow, cat. Ow, she needs to get out of here. She needs to get off of my desk so she stops biting me because I'm in her personal space. Okay, sorry for that. So total items. Now, this first time we're adding 0, and that's not really going to count. We don't want that to count. But we do want it to count once they enter a number. So we can do this in a few different ways. Let's go ahead and also print out total items entered is total items. Let's just start this like that, and we'll see how this goes. We'll run. Boop. Is it mad at something? I guess it's fine. So we've entered 0 items, do 5, we've entered 1 item, so that seems fine, right? And we will do the average. Actually, I would like these to be spaced out a little bit more so it's clearer what's going on. So I'll just do another new line here. At the end, let's go ahead and calculate the average. So average is equal to the sum divided by the total items, and print average is. So run this. We can also check our work by calculating it manually. So let's do 3, 4, and 5, which really the average should be 4 at this point. The total numbers is correct. So then the sum is 12, 3, 4, and 5. It gave us an average of 3. It should be 3 plus 4 plus 5, which is 12, divided by 3 is 4. What? That's weird. Why did it do that? So let's do some outputs just to kind of see what's going on. We can run this again. Let's do 1, 1, and 1. Because the average of a bunch of ones, okay, I see what the problem is. Here's how we're going to debug it. So we have a sum, we have our average. I'll just put this over here. We calculate that stuff. I want to print out our other variable value. So we'll say total items was total items. Okay. So we'll keep manually testing this and also checking out the numbers in the calculator. I can change this to a nicer looking thing. So let's do 3, 4, and 5. We have 3 total items. I'm going to enter -1. And now total items is 4. So what it did was 3 plus 4 plus 5, but then the amount of items went from 3 and it added 1 extra time. So it did 4 divided by 4, when it should have been 12 divided by 3. So what's the problem? Well, I entered -1 to exit. We need to make sure we only add to total items if we're entering something to put in the sum. So we could do if user answer is greater than 0, well, greater than equal to 0. Maybe they will enter 0, like if you're averaging test scores and somebody got a 0, then you could do that. So we have this, let's check that out. We'll do 3 and 4 and 5. -1, it should be at 12 divided by 3, which should be 4. And now our average is 4.0. Okay, another thing I'll mention is I'm going to put some tabs down here, and we'll see if these line up nicely or if I have to do anything else. But usually that'll kind of align everything nicely. Okay, this one has some longer text for its label, so it's not quite as well aligned. But in that case, I can just kind of space these over manually and keep those tabs, and it will look a little nicer. And there we go. So if you're trying to debug something, it can be useful to print out all of your variable values, and possibly in other places as well, just to kind of see if it has the values you're expecting them to have. Now, when we get into future programming classes, you'll have better debugging tools to kind of locate these kind of errors, but for now we can just kind of print them out and kind of look at the status each time. Let me return to these slides. Okay, validating input. Write a program that displays a number menu and stores min and max numbers. So we'll have, like, option 1, add, option 2, subtract, whatever it is. It can be any kind of number menu. And then we'll ask the user for input. If their input is invalid, which means it's less than the minimum or greater than the maximum, we'll have them re-enter their input. Once they enter something valid, we'll display thank you. Okay, so for this one, we'll have a number menu. We can just display a menu like 1. I've done some examples like this already. Let's just say buy pizza, 2, buy burrito, 3, buy hamburger, 4, quit. So we could even add like a little price to this or something, so we can add on to what the price is. So this is going to be a menu. We're going to ask the user, please enter option. Use it and store it in a choice variable. And then we have to see if it's valid. So while the choice is invalid, loop. We'll do that as the placeholder for now, even though we can't just tell the computer, hey, while that's invalid, loop. It doesn't know what counts as invalid. We have to tell it what's invalid. But basically, if it's not invalid, in other words, if it's not invalid, it is valid, then we will display thank you, and the program will end. Otherwise, we will ask them to enter their stuff again and make sure that's valid. Let's just say invalid choice, try again, choice. I'm being a little bit lazy. They're entering into a choice variable. And if we return back to this here, we'll double check to see if what they answered the second time is valid. And if not, we'll do it again and again and again. So let me just throw this over here. We'll do this as input validation. So the program starts. Let's display a menu. How do you spell restaurant? I don't remember. It's weird now. Restaurant. Okay, sorry for that little aside. We'll do 1, buy pizza. Let's say it's $12. This is a cheap pizza place. 2, buy burrito. The burrito is $2. 3, buy hamburger. Hamburger is $3. And 4, well, we don't really need to quit because, I mean, it closes the program once they're done anyway, but we'll keep that for now. So then we'll ask them for their selection. I'm just gonna add a little new line in here. I guess I could do it that way. Choice is equal to int, input, choice, and then we have to check to make sure it's valid. So I forgot to label this. This is true, invalid. So let's also store in a variable the minimum value, minval 1, maxval 4, because what if we wanted to add onto this menu? We would have to manually update any place that had 1 or 4, and it would be kind of a pain in the butt. So if we have it as variables, we just have to update it here. So we can say while our choice is less than the minimum value, or choice is greater than the maximum value, then it's invalid. Invalid. So print invalid selection, please try again. And we will have them re-enter their selection. And then we'll be good. So we'll say thank you. Let's go ahead and make a price variable. So we'll just say total price is 0. We could also add some if statements here. So if they entered something valid, we could say if choice is 1, I'm going to just put this by the side. Total price plus equals total price plus 12. Else if choice equals 2. We can kind of just align these and copy paste these. 3 and 4, really don't have to do anything for 4 at the moment. 2 and 3, and we'll print out total price. So we'll run it. What do we buy? Number 5, that's invalid. -5, that's invalid. Number 1, final price, $12. Thank you. Okay. So the next one also builds on that, and I pressed the wrong button. So we did validating input. Next, let's modify it so that we have a program loop that continues running until the user selects quit from the main menu. So the idea here is currently they can only order 1 item, but we can write a loop so that they can continue adding items to their shopping cart, basically. And when they quit, then it'll give us the total. So we have total price, min, max. We want those to stay declared at the beginning because we don't need to keep saying every time, hey, max is 4, min is 1. And we also want total price to be 0 before we do any sort of program loop because we don't want it to reset to 0 every time. Let's also do, I will say done is false, and we'll make our loop while done is false. And then we're going to indent these things. So this is going to be the end of the program. We're going to check these out. While done is false, we'll ask them for a choice. we'll do these. Let's also add else if, or we could just do else for quit. So this is going to be choice number 4. I like to write it like this, actually. We'll set done to true if they are done entering options. We'll just kind of space these out to look nicer. Okay, so once they're done, then the final price is going to show however many items they have. So all of this is inside the while loop. We'll run that. Buy pizza, buy burrito. It's not really telling me anything, but when I hit final price, it adds those together. We should probably, to make it a better user interface, display some text to the screen. So we'll just say pizza added, burrito added, and hamburger added. Run that again. Buy a pizza, pizza added. And I could space these out a little bit more as well because these are all smushed together. So we will do a new line here. Run it again. 1, 2, 3, 3, 2, 4. There we go. Final price, $22. Okay. Now let's do a number guessing game. So this one is going to loop because we want to have more than one chance to guess. If they choose something too low, it'll say too low. If they choose something too high, it'll say too high. If they get it right, cool, then the program will end. Or we could give them a certain amount of guesses before the game says game over, you lose. So let's think about this. We'll have program start. What kind of variables do we need? We need a secret number. So we could say secret number is equal to just some number, or we could use a random number generator. We also need the user's guess, which at the moment we haven't asked anything yet, but we can say user guess is 0. And we can have amount of tries remaining. So tries remaining is 5. Okay. So with our loop, we're going to say continue looping while tries remaining is greater than 0. And we could use a special break command if they got it early, if they guessed correctly early before that. So while tries remaining, let's also add display game over at the end, program end. So this will be false. So tries remaining is less than or equal to 0. That's the opposite. Otherwise, if we still have tries, let's tell them to enter a number. Guess number. Store in user guess. Then we're going to investigate to see if that was the correct guess or not. So we need an if statement. If user guess is greater than the secret number, they've guessed too high. I wonder if I can make this thinner. So we'll just display too high, too high. It's kind of hard to talk and type at the same time. Okay. Otherwise, another scenario could be they guessed too low. And in this case, they'll have to see that they got too low. And another option is they guessed the correct number. So if they guessed the right one will be equal to the other. So make sure you have 2 equal signs here. And in that case, we can display correct. And we can tell it that we want to exit early. So we could, at this point, use the break command. Let me see. This might look a little bit wonky, but we'll say break out of loop. I might put this, try to think of how this will not look terrible. So we'll say correct, break out of loop, and technically it'll come over here and finish the game. It'll say game over, you got it. We could also say how many guesses they had. And then we also have the option of what happens if they didn't get it right. So let me also put trues. They answered too high, too low, or they didn't. I guess break makes it a little bit harder to make the the diagram look nice. Set this to that kind of line style, just so you can, maybe, I don't know. Okay. So if they got it correct, we'll do that. Now, the rest of these need to converge back into where it's going to continue its loop, but we'll do this down here. If they did a guess and they got it wrong, we're going to add, or no, we have tries remaining, so we're going to subtract from that. Tries remaining equals tries remaining minus 1. Oops, close. So that is also going to converge these two scenarios at the end. And that is looking also wonky. It's not quite doing what I want it to do. And after we've subtracted from tries remaining, then we continue on our loop because we need to check to see, are we out of tries? If not, we're gonna do the whole loop again. Okay, that is kind of ugly, but I think it'll look a lot nicer in the code. Let me put that there. We will grab REPL if I can find it. Okay, new one, number guesser. So the program's starting. We need a secret number. We could do a random number. Let's make it 5 just so we can test well. User guess, we'll just set that to 0. We really don't need to declare it outside of the loop. We could have it inside the loop. This is more of like a C++ or a C style of running it. Okay, we're going to continue looping while tries remaining is greater than 0. And so this is end of while. And then within there, we'll ask them for their guess. At the end of the game, once they're done, we'll say new line, game over. And then we'll get into this part. So, inside the loop, we'll say user guess is equal to int input, guess a number between 1 and 10. Okay. If user guess is greater than the secret number, we'll display too high. Else if the user guess is less than the secret number, we'll display too low. Otherwise, the only other case is when it's equal to, but we could also write it out this way. So else if user guess is equal to secret number, we can say correct. And then we would want to break out of the loop early. Okay, so this is our if statements. But we still want to do more inside of the loop. So if none of those were true, then we've guessed. We'll say tries remaining is equal to tries remaining minus 1. And then we'll come back up to the top of the while loop, check that out, and go down here. So we'll say game over at the end. We can also say, they'll not have any tries left. We'll need to put that up here. Put remaining tries remaining, and then we can test that out. So run, guess a number between 1 and 10, 9. Too high. Okay, these are too smushed together. I don't like that. We'll redo this, and I'll add a header too. We'll say print number guesser. Stop, run. 9, 2, 5, correct, game over. Okay, let's keep answering wrong. then it says game over because this was our last try. So then there's that game. How many more of these did I write? I just wanted to make sure that we see a good representation of ways we can do these things. Okay, I'm going to do the line drawer here inside of this program. And usually I will create this sort of thing to make my programs look a little bit nicer. Also, my header on this slide is wrong. Okay, so for the line drawer, we will draw a line of asterisks a certain amount of times. We can use a for loop to do the counting for us, and it will make kind of a nice little separator in our program. So instead of asking the user how long it should be, I'll just say line width. We'll set it to 30 to start with. And anytime we want a line, we'll have to do something like for. I'll do I as my counter variable in range 1 to line width. Or let's do 0 to line width. That will give us exactly 30. Print an asterisk, and we need to make sure that there is no end line at the end. So if I run this, there's a nice line. Now, consoles, when you run them by default, have a width of 80, and I accidentally hit a button on my mouse again. There's the average program. Let's go find it. This was called, what was it called? Number guesser. Okay, so console windows usually have a width of 80, but in REPL you can't really tell because it's just resizable. So that's very long, but that's about right. So we could do the same thing at the bottom down here once they've finished one turn. So let's make this half of the line width. Now it is kind of annoying to write the for loop every time we want a horizontal rule, and it didn't output it because I think I put it outside the loop. I have to tab that over to put it inside the loop. Okay, so too low, it did not like that division, so we'll just pretend that division never happened. There. And so then it kind of looks okay. But once we get into functions, we could put this inside a function, and I can do that now just as an example. And then I could just say line anytime I want a line. And we'll learn more about this later. So now I just have to run the program. We just have this nice line function, and it draws a line whenever I want. Okay, the last one is a timer. So we're going to actually use some nested for loops in order to make a timer that counts down. Now it'll take a long time to test if we actually do seconds, but we can add a timer from Python to count down a second at a time. So let's go ahead and create a new one. We'll call this timer. We'll ask the user how many minutes we want to go down. And we'll ask them how many seconds. Okay, so we have what we're starting at. Oh, I got laundry to do. I'll do it in a minute. So we have minutes and seconds, and we're going to count down from there. So for instance, we can print out minutes, colon, seconds, and if we enter 5 and 5 seconds, it'll do that. It's not going to look quite like a clock, but it's okay for now. So let's work on counting down. So remember, with a for loop, we have some counter. Let's do M for minutes, just as a shorthand. In range, we start at minutes if we're counting down. We're starting at whatever that starting minutes is. We're going until 0, but we want it to include 0. So remember that we can't just put 0 here, it'll stop at 1. So I'm going to put -1 and step down by 1 each time. So we'll just say minutes and minutes. Run. How many minutes? 5 minutes, and the seconds currently does nothing. Oh, well, it iterated that amount of times, but M is actually the minutes we're keeping track of. So let's run that again. 5 minutes. Now it goes from 5 to 0. Okay, we can do the same sort of thing with the seconds. So S in range seconds. And we have seconds and S. However, this is just going to run these back to back. Let's do 5 minutes, 9 seconds. Do not leave the page. Stay on the page. So here's the minutes. Here's the seconds. We actually want it to count down seconds first, right? Go down like, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then after 0, we decrement. We take 1 away from the minutes. So what we can actually do is use a nested for loop. So for instance, if I put this inside of here, it'll do all the seconds iterations first, and then the minutes iterations. But this still isn't quite correct, but we'll run this. So we'll do 5 minutes, 3 seconds. Okay, that's not very readable. So let's print out, do seconds, or no, we do this the other way. Do minutes and seconds and kind of view this in a way that makes a little bit more sense. Okay, stop, run, I don't know, do something. So we have 5 minutes, 3 seconds, 2, 1, 0. But it goes down to 4 and resets the 3 back to that amount. So what happened is we're iterating, and we're not accounting for there are 60 seconds in a minute, and we're not really counting down all of that. So we'll have to put some more logic in here. Okay, so when we're iterating 3 seconds, we can display that. But if we get to 0, what happens? Well, we're done with 1 minute. We iterate down. So that will count down all of the seconds, at least what we've typed in here. And then, let's see, this is 4 seconds, and this is 4 minutes, just to kind of make those delineated. So we finished a second, and we're counting down a minute. When we're done with our seconds, how many seconds do we now have? When we go from 0 to -1, that's going to roll down by 1 minute and then set seconds back to 60. Okay? So at this point, we're done with the seconds, but we need to set seconds back to 60. The minutes, this for loop is automatically going to go down 1 minute, so that's taken care of. But we need to make sure that it resets seconds to 60. And we might need to actually make that 59. Let's double check. Let's do 5 minutes, 5 seconds. Okay, so we go up here. It does set it at 60, so let's do 59. There's no 60 second, it's 0 to 59. But we do have it counting down, so let's double check this. We go down to 0, and then we reset at 160, so let's try this again. Maybe, eventually. Oh, it didn't clear the screen. Clear the screen. Okay, 10 minutes, 5 seconds. So we start all the way up here. So 5, 4, 3, 2, 1, 0, and then we're at 9:59, 9:58, and so on. And here we're at the end. We get to 0, 0. So if we wanted this to actually be time correct, we could put in a, what was the command? Time.sleep. And the amount of seconds. So we're going to just do 1 second at a time. That's how long this is going to run. And this should actually be in here because the seconds are going to go down. It is not happy. I probably need to import time. Let me look at another script. Yes, import time. Run that. What are you mad about now? Should be fine. run. Okay, we'll do 1 minute and 2 seconds. So we're at 1, 2, 1, 1, 1, 0, and so on. So now it actually counts down by the amount. So that's an example of how we could use nested for loops. We could also do it for doing like times tables or something where we have rows and columns to work with. Here we basically have minutes and seconds, so we have two different variables that are kind of intertwined. So our two for loops let us work between both of them together. Okay, we're not actually going to wait for this to stop. It's not going to play any noise anyway. So that is all I have for these applications. The main thing that is important here is knowing how to do the program loop and validating input. Those are probably the ones you're going to do the most often. And then stuff like calculating an average, it's good to be able to think through the design, but that's not something you would want to memorize. It would be something you would kind of derive, think through the design, make a test, create it, and then test it to make sure it's valid. But at least with the programs and the classes after this one that I teach, you know, you'll have a program menu, you'll do different functions based on that, you'll have a number validator, and it all kind of works together that way.